ideally folks can hear me. Go ahead and post in the chat if we can. That would be extremely helpful. Slightly different setup today, only because I am home now, so I'm trying to get used to all of this. Let's see here. All right. Awesome. Thank you, Nanit. That helps a lot. So today we're going to essentially do a few different things. So I want to do an adjustment to the learning rate finder. This is something that I've been drafting for the last few months. Potentially, if we have time after that, I'm not sure why I have my headphones on. Potentially, if we have time after that, there's a few other cleanup stuff I want to get done. Like we'll go through and look at some bits in fast debug. Specifically the learn what is it? Sanity check that I wrote. This little bit, we're going to try and integrate that into FastAI's learner and potentially write a PR. And then if there's enough time, then we might go back and refactor a few of my open PRs. But first, let's start on the LR suggestion refactor. So I'm just going to go ahead and post this into the chat here. This is based on some work that I did at Novetta, where we sort of looked at different ways to find learning rates, because obviously FastAI has those two that it gives you, but there's also a few others that have been figured out across the way. So specifically, we have Leslie Smiths, who originally came up with the learning rate finder. We have ours at Novetta, and then we have one that was developed over at Esri. And more or less, the TLDR, what I found is Esri's version works better as a default, more than ours and more than Leslie Smith's. As to why, the others tended to select too fast of learning rates or too slow, or sometimes it wouldn't be consistent across runs, because I ran these, 3 or 4 times just to see how the standard deviation tended to be. And the Novetta algorithm did have a bit more variance to it, while the ones over at Esri, even though, yes, it wasn't, the biggest win across the board all the time, it was the most stable. So as a result, we're going to use that suggestion as the default in this FastAI PR. Now, that doesn't mean that the LR Finder algorithm is what's changing. It's exactly the same how it's been, and for those that aren't familiar, basically how it works is you train over a few batches, slowly increasing the learning rate as you go, and eventually you wind up with a plot looking like this. And then what you're trying to do is, from this plot, figure out where the best learning rate tends to be. This particular portion where we plot the plot and how we get it won't be changing. It's these specific inflection points and picking those inflection points that will be. So I've got a draft little notebook that I've sort of written up here. And what we're going to do today is take this notebook, sort of walk through it a little bit, and then convert it over into a FastAI PR and sort of figure out where probably it should match up. Because this was written as a separate project initially, not built as merge into the library, though I did have that in the back of my head as I was going. So The first thing that ideally should happen with these suggestion methods is it's no longer just pick one and that's what you're rolling with. I wanted to make it more modularized where if anyone had a particular suggestion method that they wanted to use, they just have to make sure that it's set up for fastai how it wants and then go from there. So, and I can probably zoom in a little bit on this. That looks a little small on the screen. Probably a bit better. One back. So basically how it will work is you can pass in your learning rates, which are found from the LR find suggestion, those losses, and then number of iterations. This num iterations usually doesn't serve too much of a purpose for the ones that you're used to. When we get into it, minimum and steep are the fastai ones. These are more for the Esri and the Novetta algorithms. Now, if you need like any other complex functionality with it, you just write a partial function and go from there, and specify whatever else it is you needed. If you needed, for example, num iterations. Pretty sure though with this method, the bare minimum needed is LRs and losses. But anyways, so in regards to how this all works, if we go over to the usage right here, so at the end of the day, what essentially will happen is you'll build your learner, and then you'll call LR find, and you'll pass in some suggestion funcs. And the four that are passed in here are that minimum and steep, which are the fastai ones, valley, which I want to say is the valley is the one out of Esri, which this will become the new default. And then the slide method is the one developed by Andrew Chang formerly out of Novetta. And it returns a named tuple. So if you want to grab each individual learning rate, we can either have 4 returns or grab the named tuple. Any brief questions over any of that? I know that was very quick and high level, but this will be more so looking into how do we take what we've done here and bring it over to the fastai notebooks and notebook dev and all of that and build a PR. Little more than the meat and grits behind what's actually going on here. Go ahead and but if you make sure that no one's trying to get to me over in the Discord. But it looks like we're all pretty okay, so let's go into the little more complicated process. So how can we do this? I'll go ahead and save this as a GitHub gist. And what I will do is post this in the chat. Because what we're going to wind up having to do is I'm going to have to take this off screen. So there's the notebook for folks to look at. Because now we're going to have to go into here. So ideally for this part, this will probably go into callbacks because that's where all that's working. First, let me go through and make a PR. So I have a quick, easy little bash script that runs. that will go ahead and make a new fastai PR for me, like set up my local branch for me to use. We'll call this auto LR. Now, as to where this is, go to my gists. It should be here. For those that want it, there is the link to essentially the bash script that I run this on. More than likely, it's easier to do this with what's it called? With the GitHub API. I just wrote this, got used to it. Haven't really found a need to learn the new Git API yet, much to Hamel's dismay. But we'll get there one day. All right, so now we have a new AutoLR branch, and it's just the fastai GitHub. So next, we're going to go into the notebooks. So fastai notebooks, and I want to say callback schedule is where this lives. We'll find out, but that's what I want to say. Oh. All right. Here we go. Yep, the LR finder. All right, so this is what we care about. Now, generally, how my development cycle and platform works for this is I'll adjust the notebooks locally. I won't run anything that needs like, CUDA or anything complex. And then usually I'll test it in GitHub since I don't have a local GPU and then just pull it back. Or I'll just open this exact notebook up in GitHub, which sounds a bit more optimistic for this particular case. So let's go ahead and do that. So if we do collab, I'm going to go ahead and go to my one that has the good GPU. Go GitHub. Select my fastai repository. And for those wondering, yes, most of the time when I don't have access to my local GPU, I do my dev work directly out of Google Colab. We want, which notebook did we say? 14, callback, schedule. And change the runtime type. Now, I'm not going to actually follow this. Strictly because I want to work out of the dev environment. So I'm going to do and by dev, I mean directly working out of fastai's GitHub repository. Which this little bit quickly just pip installs any GitHub repository you want, so long as it has a setup.py. So we'll quickly let that install and then move a little further from there. All right, there we go. Go ahead and get rid of that just for helping my sanity's sake. We'll also need to install nbdev. All right, and now we can get to work. We're going to go ahead and just run all of these real quick. All the way down to our learning rate finder. There we go. All right, so if we follow based on what I had, we specifically modify lrfind and plot lrfind. So lrfinder in of itself doesn't need changing. We can go ahead and skip that. That runs for 10 seconds, so I guess we can let that go. And just quickly make sure that everything runs. All right, so now this is where we need to modify a few things. So the first thing that's currently going through my head is how we want the documentation to flow. Because ideally, yeah, I guess that works. All right, so let's do this. We're going to make a new section. And let's quickly look at the docs. What I'm curious about is how this shows up. So if we do recorder plot schedule. All right, so we have class param scheduler. I'm actually not a big fan with how these docs are formatted in this particular section. So let's see how we can't manage to improve that a little bit. Let me go get my cat. And he's just going to sit outside the open door. All right, that's just how we're going to roll with things. So there's quite a bit that I'd like to improve with this. Now, how Jeremy states it is PR should be small and incremental. So completely rewriting the docs like this probably wouldn't be a good thing to do in this PR, but that's okay. There's a way that we can get past that. For now, let's just focus on the implementation. So since I want to override plot lrfind and basically rewrite it, we will go ahead and make our suggestion methods documentation down here. So we'll do suggestion methods. And honestly, this documentation in of itself should be fine. I'm just verifying really quickly that number of iterators is actually needed. Yeah, it is. So there are a few methodologies for suggesting a learning rate automatically. And these, as we will see, can be further passed into LR find. Below are the four methods current. Currently, four methods are supported. If I were to write your own, it should look like a function that can accept LR finders, returned learning rates, losses, as well as the number of iterations. Your function should return an XY coordinate. That can be plotted so if we quickly type annotate this, that way it's clear for folks. So LR should be a list. Losses should be a list. Number of iterators should be an integer. Return a tuple of... Hey, Carlos. Nice to see you. Hope you're feeling okay. We'll do a... Suggestion should be a float. And then a tuple of float int. See how that looks. Yeah, that looks fine. Speaking of which, how many people do we have in here? Okay, not bad. So we have a function, myfunc, takes in some learning rates, some losses, and some number of iterations, and returns a tuple of a float and an additional tuple that is a float and an integer. And then, as it says, if there are more parameters to be passed in, you should pass your function as a partial and specify them yourself. We can make that example a little bit more clear, I think. Sorry for the cat if it happened to show up. So we can do, for example, percent reduction, float. Obviously do something with percent reduction in there. And then we'll do myfunc percent reduction 20%, just as an example. That way it's clear to folks that this is how it should look. Now next, we are going to want to write a few suggestion methods. So first one we'll pull over is that slide method. Now, for the sake of fastai, I don't think we want that annotation because we don't really use the return annotations. That's why instead I opted for just showing it in the documentation here. What we can do though is number of iterators is an integer, int, float, float. All right, so that works. And adjust value will set as a actual float. So suggest the learning rate, following an interval slide and returning the index. We'll go ahead and make a few code cells. Doc slide. Just that way we can visually see it. And then some quick information about it. Now, the other thing we'll probably want to do is write a quick example and make sure that it works okay in case someone decides that they want to change the algorithm in the future. We have a small little test for it. So what we'll do is learn equals synth learner LR finder, and if we go back to this, all right. All right, so now if we do, I think it's under learn.callbacks, right? Learn.recorder. LRs, there's our learning rates. I'll go ahead and bring this to 5. That way we can visually see it. This won't be part of the notebook, but this is just for us to look at. And then learn.recorder.losses, recorder. We know our numerator is 100. So what we can do is go. Actually, what we'll do here is put this in a hide. This is more for testing. We'll do slide learn.recorder.lrs, learn.recorder.losses. Iterators was 100, and this is roughly what we got. So we'll do LR tuple. Go ahead and hide this because it doesn't necessarily matter. Yeah, I guess it does. We'll go ahead and show this. How do we want to probably format this? Yeah, I guess these can be hidden. And then, since the LR finder can be random every time, I don't think we necessarily want to write a test for this, because we're not necessarily setting explicit seeds all the time. Jeremy and I had a long discussion about this, about reproducible results out of the learning rate finder, and technically it's impossible due to just some randomness in general, as well as just how floats operate. So you won't always get exactly the same result, and sometimes you won't even get too close of results. So I guess we'll just keep it there for right now for folks to look at. All right, so there's our slide method. Next up, we have the valley. And it's detailed here. Actually, let's go to our defaults, which would be our valley. The longest valley and returns its index. Like the losses, max start, max end. Make sure there's nothing we can sort of simplify here. Nope. So basically how this works is it looks roughly 2/3 up the graph that we saw. I can scroll a little further. It'll look roughly in here, which is give or take 2/3, and then find the steepest slope within that. And so what this allows is we're no longer looking in these particular areas where you essentially have the extremes. All right, so we'll have our valley, and we'll do something very similar to what we did before. We'll write our documentation, and then make sure that we have some proper attribution in the documentation. So we'll probably need to rewrite this a little bit. The valley algorithm was developed by Esri. We can probably link to the forum post for that one as well. So we go through here. This is the one we care about. And it's more straightforward approach. And takes the steepest slope roughly 2/3 through the longest valley in the learning rate plot. Is also the default for learner.lr find. All right, so that works well enough. Now, if we, yeah, okay, I'm unmuted. Do valley, we compare it to slide. So we can see that they give us two radically different learning rates, which, if you play around with these, isn't something that should be surprising. Because what you're going to wind up finding is each of these work slightly differently. Some work better than the others, and as a result, the differences will vary. So we'll go ahead and hide this just so folks know this is how you use it if you open up the notebook. And then we'll go back to the ones that fastai already has. So these would be the minimum and the steepest slope. So suggest a learning rate 1/10 the minimum before divergence and returns its index. Now, the important thing here is we're changing a default. fastai by default did not divide it by 10. Or it did divide it by 10, but it didn't tell you it did. So we're going to change that documentation a little bit and also return the original learning rate here. So we'll do doc, minimum. We don't necessarily, what we can do is do minimum and steep. Go ahead and grab our quick little examples. Where'd we go wrong? Oh, this should be minimum. And apparently we messed up a little bit. Let's see if we can't fix that. Ah, that's our issue. So what we need to have happen here is probably to do a torch.stack. And then if we look at I just want to make sure I'm doing my math here is all. Because I don't believe we want to set the dimension to 1. Yeah. Or -1. And then what we should see is if I've already done so. So basically, if we double wrap a torch stack, this should still wind up being the same thing. Well, that did not go how I was hoping it would. If not, is instance. Well. No, I guess that's always needed, I guess, because that's how the losses winds up working. So we'll do. Because I don't think we wind up using losses besides that. So we'll do losses. We'll do min. Argmin. Torch.stack. Losses. Argmin. Now I'm doing it this way rather than like trying to find a special workaround because this is always consistent and well, what I was expecting to happen is it should just work flawlessly, more or less. And I think it's partially due to a torch bug. This code worked like a few months ago. And the only thing that has really changed in regards to these little things and these little nuances is upgrading the torch. So I could believe that how this behavior operates might be a subtle little change in the new torch version. Because what should happen is rather than getting back a list of tensor bases, it should be one giant tensor base. Yeah, very, very fun times with the new torch version. But now that we've got that fixed, because essentially this should always work no matter what, I'll go ahead and test it just to be sure, but that should be fine. And yeah, no problem. So if we do that, okay, now this should hypothetically work. float object. Interesting. Ah. No wonder why I'm getting such weird results. We should change how this looks. It helps when you look at the source code. So the reason why we're running into so many issues is because of this. fastai already converts it into something usable. So we'll go ahead and do this down here. We'll do learn.recorder.losses, 100, 100, which I think is what I do up here anyways. Yeah. All right, that's a bit better. So now if we go through and run everything again, we don't need this. We just need LR's losses. There we go. That looks a little bit more torchy. So we'll go ahead and get rid of LRs and losses. And then again, LRs losses. As a result, we have to basically undo everything we just did here, which is just that, I believe. Beautiful. Okay, well, there's one little live code debugging that we got through. Didn't kill us too much. How are we doing stream-wise? 4 of you guys are here with me all the time. I appreciate it as we go through this madness. So, we got minimum working. Then we just have to get steep working, which would be hide, steep, LR's losses, 100. Cool. All right. So now we have 4 different working suggestion methods. Now we need to ideally split this up a little more. Finding a learning rate. That work? No. Because I do want to split this up, documentation-wise. I guess that's fine. We'll keep it this way for now. Unions API function. Yeah, well, let's get rid of that for now. All right, so plot LR find needs to change because we have a bunch of names that we need. Now, where the names come in. We have names for each of our functions, right? Each of our methods. So we need a way to plot that. Now, suggested LRs should also change, I believe. Where did I go through and modify that? Or did I at all? I don't think I did. Yeah, I didn't because it's integrated in there. And the reason for that is this can change. Because basically, depending on what names we pass in, that named tuple can change. So we'll go ahead and copy over my new version, which has a bit more into it. Where do quarks get passed? I was about to say, we don't use quarks at all here. So I don't really think we need it. Go ahead and get rid of that. Now, suggest functions by default. We should use our valley. And return suggestions based on suggest funcs as a named tuple. This should be self rather than learn. Welcome to how I figure out what's in fastai or not. I Google search it. There was a way, or I should say there is a way that fastai figures out the names of things, which might be fastcore. Yeah, because it should be in the transforms name. What does this look like? Yeah, that's not really important to us. All I was trying to do there was figure out a cleaner way to do this. Deal with partials. Number epochs. Go back. Self to fit. All right. First introduce cyclo finder, then plot loss first. All right. Variety of learning rate suggestion algorithms can be passed into the function. By default, we use the steep suggestion. We use the steep. Paradigm sounds better. Now I do remember at one point in time, Jeremy had wondered if we could make that into a little namespace. He might modify the PR and ask for that. If he does, I'll go ahead and show you what my backup plan is. So FastCore has something called make class, which basically is a convenience function to basically make a class based on a few inputs or a dictionary. So we'll do, for example, make class suggestion method, and then I'm trying to remember how this expects it. I'll go ahead and pull this up over here so you know where I'm going to. When I'm trying to remember how make class works, I normally go to vision augment because pad mode has it. So if we do O dot lower for O in A B C dot split comma. All right, so that makes sense. So here we'd want it to be O dot name, right? Because steep, nah, string steep. There we go. That's what I want. Yeah. O dot underscore underscore name. Wonder why that didn't work. Name and then O. O N, and then we'll do steep. How do we wind up doing this? It was steep, valley, slide, minimum, steep. Valley, slide, minimum, steep. We need our star there. So now if we do suggestion method, dot minimum, oh, what is the proper case? It's capitalize? Yeah, dot capitalize. So here's basically what my backup is. We have this little class called suggestion method that holds a few different of our... Actually, I like this more. I like that a lot more. So probably what we'll do is let's take a look at how we did this for vision. Because what we did here is we had pad mode that had zeros. Yeah, see, the issue here is, in this case, they're a bunch of strings. In our case, they're a bunch of functions. So for now, I'll leave it as is. But I will go ahead and do this. Doc all possible suggestion methods as attributes to get tab completion and typo proofing. And we'll go ahead and put this in here. And then here we'll do suggestion method dot valley. Convenience attributes. And then what we'll do is if Jeremy doesn't like that, then we'll go back to the old way. But we'll see how it goes. To me, it logically makes a little more sense to have this in here. That way folks will know what to look for. But I'm not sure if the benefit of actually making it a separate class like this is worth it. And if instead these should maybe be private functions or something. That way they can't be found as easily, though they want to be found easily. Well, welcome to the ideas that wrap in my brain. I think I'll leave it as is for right now. Might be overkill, but there's nothing wrong with overkill. Most of the time. So now that we're done with that, and now all we need to do is plot it. So with temp, waits pre-find, waits post-find. Suggest funcs. We'll do minimum, steep, valley, slide. And let's see how that looks. LR min, LR steep, LR valley, LR slide. Awesome, there we go. So now let's print it out. We'll do minimum divided by 10, LR min dot 2e, steepest point, LR steep, we'll do longest valley, and then slide interval, slide. Let's see how that looks. So That's not bad. Although here, just to make my life easier, I think we want to do these as new lines. And then we'll also do tabs to make sure that they're all formatted pretty. Perfect. All right. There's the hard part. We now have our suggestion. And we are now ready for a PR. And it only took us an hour. For those of you still with me, I am amazed by your perseverance. Because it's getting pretty close for me. All right, so we've got this done. It works. Documentation is how I want. It roughly works out how I'd expect it to. We have some tests. So now let's go to the NBDev part. Now, for me, what I do is I'll download the notebook off Colab, upload, give it a moment to refresh itself. I'll usually then re-upload it, make sure that it's named properly into my Git repository. Go ahead and overwrite it. Build lib and clean notebooks. Now, since I already ran it top down there, I know the test passed, so I'm not going to do it locally. We're also streaming. I'm not going to go through the time to do that. But for those unfamiliar, this is how you make a fastai IPR. So let's start from the top. When writing a fastai IPR, usually what happens is, so first you noticed I wrote everything in the notebook and not in the direct.py files. So this is because fastai is built off notebook dev. So the next stage is building the library. That's this nbdev build lib. And then we need to clean it and remove all of the specific Colab metadata. And so that's this nbdev clean notebooks. Now, after that's all done, we'll see that 3 files have been changed here. Callback.schedule.py, callbackschedule.ipy notebook. Also, this might be a little small for you to read. I'm sorry about that. I don't think I can change it, but we can try. Yeah, it helps a little bit. And underscore nbdev. Underscore nbdev is nbdev's way of keeping track of all the indexes for the documentation where like everything needs to go to. So next we'll do git commit -am. Now this is so that I can do git add and git commit all at once. It should be noted though that when you do this, if you added any new files, it won't pick up on them. So you have to go back and add manually. We'll call this finalize new suggestion methods and algorithms. All right, we're good to go. And then we'll do git push origin auto lr. I will go ahead and grab my git password off screen. And there we go. We're now pushed to GitHub. So how do we make the infamous PR into GitHub? Let's go take a look. So I'm over in the fastai Git repository. We have the pull requests, and I say, oh, let's make a new pull request. Compare across forks, and go find your fork. So mine, I want to say is under Mueller's ER. We're going to find out in a moment. I did it under Walk with fastai. The joyous moments whenever you have two different GitHubs that you keep track of. Auto LR. And now we have our pull request. So we can see that we have valley slide minimum steep. That got picked up. We got rid of suggest LRs. And we added a whole bunch of things. Awesome. Now we need to write this in such a way that it's easy enough for Jeremy to take a look at it, understand what we did, and be able to basically approve it whenever he eventually gets time to look at it. He's currently super busy right now in Australia planning things, so it's a little slower right now for the time being. We'll call this enhancement. New and improved LR suggestion paradigm. Now, let me go pull up an old PR of mine, and I'll show you the general format that I think I like and looks pretty well. This would be the... I want author. Here it is. So a while ago, I made a pretty big change to DSIDX and added some tests. So I just added a quick summary of the changes, end users, and added tests. Now, personally, I like this little format. It looks clean, gets it pretty organized fairly well. So we will go ahead and copy what I did here for our new PR. So go ahead and open this in a new window so that way I can take a look at it as we go. So we'll do summary of changes. This PR introduces two new suggestion methods, well as a new way to plot LR suggestions based on research performed at Novetta. We'll go ahead and link our little article, which I don't think I have anymore, but we can go ahead and copy the link to that. Actually, I had a better one than this. Let me go take a look. Yeah, this is the one I want. So, a while ago, we changed how fastai can determine the right device even with torch data loaders. And I wrote my PR pretty explicitly. I know a lot of people tend to write very short PRs and don't leave a lot of information in. Try to, please. It makes our lives easier when we go and review it, and that way we can look at it, understand this is what we should prepare for before we go and look at the files changed. So we'll go ahead and copy what I did here. So, suggestion methods. Introduced 4 new suggestion methods. Or I've introduced 2 new methods and kept the 2 originally from Leslie Smith paper. These are steep. No, it was like steep. I always remember steep out of all of them. Valley. Slide. Minimum. And steep. During experiments, we found that valley consistently outperformed the other three. So as a result, the default for FastAI's learning rate finder has been changed to use the valley suggestion. Though as many LRs as wanted can be passed in. Do want to check one thing though that I just thought about. Yeah, so most we can plot 9. That is a silently failing thing. So we'll make a note of it in the LR. As many PRs can be passed in, more than 9 likely will have issues with the coloring. Suggestion method should take in 3 params. A list of the learning rates. What was it? Learning rates, losses, and number of iterations, all found from the LR Finder class. What this does for end users. Since FastAI wants to be on the edge of machine learning, I guess deep learning, this PR ensures that we are ahead of the curve and using, so far, has been seen to be the best way to estimate learning rates automatically. What else do we do here? Document potential. Along with this, each func currently lives in a class. Suggest func. Should these functions be privatized, or is the namespace class too much? It's a nice convenience function, but I know FastAI wants to keep naming to be pretty unique. Which, if you're not aware, Jeremy likes to make sure that when you do that dot star, that very, very scary dot star that fastai does, that it doesn't happen to override anything. And so that's why fastai's sort of functions and callbacks and everything are named the way that they are. It's so that way when you do that import star, nothing's a surprise. Since fastai I want to be planning, we'll go ahead and grab a picture of what our new plot looks like. Below is an example plot with a usage example with usage. Actually, what we'll go ahead and do here is since technically we just want an example, we can just show the whole thing. Beautiful. All right, let's see how this looks. Summary changes. This PR introduced two new suggestion methods. Minimum and steep were the two originally in fastai. And did we add any necessarily tests? No tests were added since the LR finder can be pretty randomized, but under some hide tags are the outputted results and usage when passing in the raw LR finder results to each paradigm so devs can see an example. Right? Yeah. Okay. And then we CC at Jeremy and create the pull request. And there we go. We now have our pull request in. And with that, hopefully within the next week or two, Jeremy will take a look at it and maybe it gets in the library. That'd be pretty cool. So I'm pretty tired. It's 8:30. We've been going for an hour and a half. So I'm probably gonna stop it for today. If we were to do this again, because I do want to do one more for the fast debugging, I'll probably do it Friday if I have time, so you can keep an eye out for that. But thank you guys for joining me while we sort of got a few what's it called? Spring cleaning items done, because I've been trying to do this for way too long. But that is all. Thank you guys very much for joining me on the stream.